Welcome, everyone. Today, we're going to explore a very important topic in the realm of Python and cybersecurity: the security risks associated with Python pickles. Pickles are widely used for serializing and deserializing Python objects, but they can pose serious risks when handled improperly. This presentation is supported by the NSF AI Institute for Action, where we specialize in agent-based cybersecurity research and operations. Let's dive into the topic and see how something as innocuous as a pickle can become a security threat. Let's start with a basic question. What are Python pickles, and why should we care about them? In Python, pickles are used to serialize and deserialize objects, meaning they allow you to save complex data structures or models to disk and reload them later. While this is extremely useful, especially in scenarios like machine learning, it becomes dangerous when you're loading pickles from untrusted sources. Pickling allows for the execution of arbitrary code when unpickling, which can be exploited by attackers. This makes deserialization from unknown or untrusted sources a potential vulnerability. Now, let's understand how pickling works in more detail. When we say pickling, we mean the process of converting a Python object into a byte stream, which can be easily stored or transferred. Later, you can unpickle this byte stream to recreate the original Python object. For instance, if you train a machine learning model, you can pickle the model and save it for later use instead of retraining. This sounds great, but the risk arises when we load or unpickle data from an untrusted source. Since the unpickling process can execute code, if the data is tampered with, it can execute harmful code on your system. So what's the core risk? Unpickling is essentially like running a script. Anything within that pickle file can be executed. Imagine if someone sends you a malicious pickle file that contains a script to delete all your files or give them access to sensitive data. When you unpickle this file without verifying its source, you are essentially allowing that harmful script to run on your system. This is why pickles from unknown sources are so dangerous. If you don't know where the data is coming from, it could be compromised. Now let's take a look at a challenge from the recent iCTF held in 2023 by the Action AI Institute. In this challenge, participants were asked to submit serialized scikit-learn models, which the server would decompress and unpickle. The problem arises when the server doesn't properly validate the pickle file, allowing an attacker to upload a malicious pickle. By using pickle's ability to execute code, an attacker can inject harmful commands that execute when unpickled, potentially gaining access to the server or corrupting it. This scenario demonstrates just how critical it is to validate data before deserialization. Let's take a closer look at an example of a malicious pickle payload. This specific payload uses the os.system function, which allows shell commands to be executed. In this case, the command /bin-h opens a shell on the system. When the server deserializes this payload, it effectively runs this command, giving an attacker shell access to the system. This is a clear demonstration of how dangerous insecure deserialization can be. Without proper validation, you are allowing untrusted code to execute on your system, and the consequences can be severe. What are the key takeaways from this? First and foremost, never unpickle data from an untrusted or unknown source. This is the most important rule. If you're working with pickles, always ensure the data is coming from a trusted, verified source. Second, it's a good idea to use safer serialization formats like JSON or YAML, which don't have the same security risks as pickles. Third, if you absolutely must use pickles, implement security measures such as sandboxing the environment or using digital signatures to verify the integrity of the data before unpickling. These precautions can help mitigate the risks of remote code execution or system compromise. So, how do we protect ourselves from these kinds of attacks? One obvious solution is to avoid using pickle for untrusted data. Instead, we can switch to safer serialization methods like JSON or YAML, which don't execute code during deserialization. If you do need to use pickle, you should consider hardening the process by adding security layers. For instance, you can validate the pickle data before deserializing, or use digital signatures to ensure that the data hasn't been tampered with. Another option is to sandbox the environment in which the deserialization happens, limiting the potential damage if a malicious payload is executed.